Often called multi-chassis link aggregation or MC-lag on different vendors' equipment, Cisco's virtual port channel VPC allows links for two different Cisco Nexus switches in different locations to appear as a single port channel to an endpoint device. This eliminates a single point of failure on the Nexus switches because even though they could be geographically dispersed, even if a DC was to fail, there would still be full redundancy to the other peering Nexus device. Now, there are a few terms that we will familiarize ourselves with before jumping into the configuration. VPC uses two Nexus devices, one as the primary and one as a secondary. A peer is the other Nexus device. The peer keep alive link provides layer 3 communication to determine whether the peer is functioning correctly. The peer link, this is used to synchronize communication between the VPC peers. And finally, the VPC domain, this identifies the virtual port channel and must be the same between peers. A very important layer 2 technology if you're dealing with the Nexus switches is VPC, which is virtual port channels. And on other vendors' equipment, we might call this multi-chassis link aggregation protocol, or MLAG if you're working on Aristas. And basically what this is a port channel, but the port channel is connecting to two different switches. Guys, I have a request from you. If you're enjoying the free content, I'm looking to increase my subscriber count to 4,000 subscribers by June. But I can only do that if you give me the Play Special. Do you want to know what the Play Special is? Press like and subscribe. Okay, back to the video. So let's have a look at our two different Nexus switches. So let's have a look at the topology that we're going to be working with. So we've got Nexus 1 and Nexus 2 with 3 links. 2 of these links will be in a port channel, which is called a peer link, so that they have communication across them and they can synchronize. And then this Ethernet 1/5 will be what we call a peer keep alive. So this is just sending keep lives to make sure that the other switch, rather than sending data and synchronizing, just that the other switch is functioning correctly. And then we have Ethernet 1/1 on both Nexuses going down to a switch. And the switch will see these two Nexuses as a single switch. But obviously, as we can see from the diagram, logically there will be a single switch, but physically there'll be two separate switches with these peer keep alive and VPC peer links between them. So let's get into the configuration. I have Nexus 1 and Nexus 2 open, brand new, so I will have to skip this auto provisioning section. And all this is doing is disabling POPE, which is our power on auto provisioning technology. And we're going to have a look at that, but that will be at the very end of the course. All right, let's log in. And I actually like this white color that's coming up now, so let's just do a conf here. We'll leave the screen like this. Let's put in our basic configurations. So username, admin. Whilst we're waiting for that, we'll jump onto the other switch. And the first thing that I'm going to do, I'm going to actually segregate that keep alive traffic. So I'm going to put it in its own VRF with its own VLAN, and that's all that's going to go across this. So I will have to use also an SVI, which is a switch virtual interface. And to do that, I need to enable that feature. And that's just feature interface VLAN. Now we could do the VLAN configuration. So VLAN 15, I'm going to name it as keep alive. And then we're going to put it in its own VRF, which is also going to be called keep alive. And it's going to be using, let's have a look at the diagram again. And our keep alive link is going to be this top link, which is going to be Ethernet 1/5. Make that a switch port, access VLAN 15. Make sure you always no shut your interfaces on the Nexus platform because they're down by default. So we're going to make a SVI now, interface VLAN 15. This is going to be in VRF keep alive, so it's going to be a member of the keep alive VRF. And if you had configured an IP address here previously, it would wipe it out as soon as you make it a member of the VRF. Just something to take note of. We're on Nexus 1, so... And this keep alive is just a layer 3 technology. It's layer 3 for the keep alive. Let's no shut that interface as well. No harm in doing a copy run start on this. Do the same on the second one. So interface VLAN 15. And the reason it goes red here because you need to do that feature interface VLAN. I was just showing you that really. So feature interface VLAN. Let's make our VLAN 15. Name is keep alive. Make it in its own VRF. So that VRF will be called keep alive as well. Now for interface E1/5, make that a switch port. Make it a member of that access VLAN. No shut that interface. VRF member is called keep alive. Now shut that interface. Now I should be able to ping the other side. So ping 192.168.1.1 in its VRF, which is keep alive. First one is ARP and it's pingable. Okay, excellent. So let's do a save of that configuration. Now we're actually going to create our VPC, and the first thing we need to do again here is, again, we need to enable that feature. So if I show you first, before I do that, if I say show feature, and we're looking for the VPC, we can see that the VPC feature is currently disabled. So we need to enable that. So feature VPC. And the domain name needs to be the same on both switches. So VPC domain, let's just say 10. Okay. Now for our peer keep alive, the destination is going to be the other side, which is 192.168.1.1. And our source is the local. We're on Nexus 2, so 168.1.2, and it's in the VRF, which is keep alive. If I say show VPC peer keep alive, we see it's currently suspended because our destination IP is not reachable through this VPC, and that's only because I haven't done the configuration on the other side. And we said even though we're sending them, we haven't received any. So let's do that configuration on the other side. Feature VPC. Our VPC domain is 10. Peer keep alive. And the destination is 192.168.1.2, and our source is 192.168.1.1 in our VRF, which is called Keep Alive. Now we've done that configuration. If we look at the peer Keep Alive again, show VPC peer Keep Alive, and our peer is alive, it's sending and is successful, and it's receiving is successful as well. And our destination is 192.168.1.2. Okay, that is it for the peer Keep Alive. And this is just showing that our peer is up. Now we need to actually do our peer link to be able to do communications between the two peers. And to do that, we're going to be doing it on, let's have a look at our diagram. E1/3 and E1/4, they will be in a port channel. So let's do that now, and we'll do that as a range command. And to do a range command, we just do a dash between the two of them on the Nexus platform. So interface E1/34, will they have their own VLAN? No, I don't think so. Okay, so what I can do here, I'm going to make them, oh yeah, that's what I need to do. I'm going to use LACP, and to do that I need to enable the LACP feature. So feature LACP. Now we can do the range command. And because we're using interfaces 3 and 4, I'll just make the channel group 34. Mode active. Okay, let's bring those interfaces up. Interface port channel 34. We're going to make it a trunk between the two of them. So make that a switch port. Switch port. Mode trunk. Switch port trunk. And I only want to allow VLAN 34 across this peer link, but I haven't created VLAN 34. So let me do that now. VLAN 34. And what I'm going to do, actually, I didn't do this. I'm going to put these switch port, access, VLAN 34. Okay, now interface PO34. And all I've done is put interfaces 3 and 4 in VLAN 34. And then I'm going to trunk them across this link on the port channel. So for port channel, I've made it a switch port mode trunk. So switch port, I'm only going to allow VLAN 34 to cross this for the peer link. Switch port trunk allowed VLAN 34. Alright, now we're going to make it a VCP peer link. And we've got a message coming up here saying, please note that the spanning tree port type is changed to network port type on a VPC peer link. This will enable spanning tree bridge assurance on VPC peer link provided the STP bridge assurance is not disabled. Now, spanning tree, it sends out BPDUs to communicate and determine which interfaces are blocking and which ones are forwarding. And it's usually a one-way process where the switch will send out a BPDU, but it's not going to expect a response. But with bridge assurance, it's going to modify that behavior and enable all operational ports, including the blocking ports, to send and receive BPDUs so that it could be notified of any malfunctioning switches. And for this to work, the port has to be defined as a spanning tree network port. So let's see what happens if we don't leave it as a spanning tree network port. Show VPC. And we see that the peer link is down, and it's due to the peer configuration currently. So let's go and do that configuration on the peer. So VLAN 34, interface E1/3 to 4, switch port. They're going to be access ports in VLAN 34. And we're going to make a channel group of 34. Mode is active so that it uses LACP. LAC process needs to be starting. Okay, so feature LACP. Let's see if we could get that port channel up again. Good. Let's now shut those interfaces. Now interface PO34. What am I doing here? I'm making it a switch port I'm making it a trunk. Switch port mode trunk. And we're only going to allow VLAN 34 to cross this trunk. Switch port trunk allowed VLAN 34. And we're going to make it a VPC peer link. We're going to have a look to see if anything happens. Show VPC. And the link is down. And it's due to the peer configuration. So let's see about putting this spanning tree port type as a network port on both sides. Show VPC. And the peer has formed okay, and we're going to do that on the other side. So if you don't make it a spanning tree network port, the VPC peer link will not come up. Show VPC. And we see that we have success on both sides, and our peer adjacency has formed okay. And it's used in port channel 34. Okay. This is it for the Nexus Keep Alive link and the peer link. Now we're going to do the configuration down to our switch. So down to this switch, we're using ports E1/1, and we're going to make those access ports. So on our Nexus, interface E1/1, switch, sorry, let me say VLAN. We're just going to call it VLAN 10, interface E1/1. Switch port, access, VLAN 10. Alright, so make it a switch port first, switch port. Now switch port, access VLAN 10. And I know that there's some issues sometimes, so I'm just going to force it to join that. And it's going to be channel group 10. I'm just going to say force. We're not going to use any LACP or anything down to the switch. No, shut that interface. And also our port channel is going to be an access port in VLAN 10. So switch port access VLAN 10. And the important part is here to make its VPC of 10. All right. Show port channel summary. Let's have a look. We should have 2 port channels. Yeah, so 10 is the one that I'm looking at. That's the one going, it's currently down, and that's the one going down to the switch. Let's do that same configuration on Nexus 2. Interface E1/1. Make it a switch port, access VLAN 10, which I haven't created yet. It should create it. No, it did not. Okay, channel group 10 force. Let's now shut the interface. Show VLAN brief just to see if it created the VLAN, which it did not. So we're going to create that now, VLAN 10. Okay, VLAN 10 is there now. Interface PO 10. Switch port, access, VLAN 10, make that VPC 10. Now shut that interface. And then we're going to jump onto our switch and do our configuration there and see if the Ether channel comes up. So this is our switch, just a default config on the switch. Show IP interface brief. Nothing on the switch at the moment. Interface range G0/0 to 1. Okay, let's say VLAN 10. Go back to the interface range. Make it a switch port. Access VLAN 10. And channel group 10. Just going to say mode is on. It's not using LACP. Now shut those interfaces. And for interface PO10, switch port access VLAN 10. close shut. And let's see if we've got do show ether channel summary. And we can see that our ports are both up. So if I do show CDP neighbors now, I should be able to see our connection to Nexus 1 and Nexus 2. Show CDP neighbor. Yeah, and everything looks like it's working fine. Alright guys, that's it for VPC. There are some additional commands like the VPC peer gateway and things like the VPC peer switch is like where to a downstream device it will make the pair of VPC switches appear as a single switch to the spanning tree domain. But we don't need to concern ourselves with this. It is something that you can read up on. I would advise reading up on it. But for basic VPC and just to see how it works on a Nexus, we're finished here and we're going to see you in the next video.